Alrighty, I was asked to do a video about the kinematics formulas, and that's what physics and honors physics are working on right now. When we look at the kinematics formulas, we're going to be taking our descriptors of motion. Displacement, which could be delta x or delta y for horizontal or vertical motion. Acceleration, time, and velocity, which could be initial or final. And with those four basic descriptors of motion, we're going to be able to predict anything about the object's motion that would occur at a different time. So when we're working with the kinematics formulas, none of the variables are unfamiliar to you. The trick is to identify in the problem the information that goes with the relevant variables and then choosing the correct formula to effect a solution. Now remember, units give me an idea as to the identity of information. So displacement, the meter, or it could be kilometer or centimeter. Acceleration, meter per second squared. Time, seconds or minutes or hours. And velocity, meter per second. Now do watch, especially for these three. If they're given to you in a unit that's not the standard SI unit, you will need to convert. So if we take a look at a sample problem, and this is number 24 in your book, of the chapter review actually of your book. A sailboat starts from rest. Now remember, from rest is code. For initial velocity is 0 meter per second. Comes to a stop is final velocity is 0 meters per second. And accelerates at a rate, so acceleration equals 0.21 meter per second squared over a distance of 280 meters. So that's horizontal to 280 meters. And the problem asks me to solve for two things. One is final velocity and one is time. Now, in this particular example, starting with final velocity, I always set up my problems this way. I always set them up with the variable equaling the value. This way, when I go to choose a formula, I have all these nice little letters staring me in the face. That allows me to go to a formula that's filled with letters and find the one that's going to match up with what I have. So I look, and I have a formula that looks like this. Vf squared is Vi squared plus 2a delta x. I'm looking for that. That is on my information list, and so is that, and so is that. So this formula is going to work. Vf squared, and I'll put a little right here, Vf squared is 0 meter per second squared, so that's nice and easy, plus 2 times our 0.21 meter per second squared times 280 meters. Now I can't forget that when I multiply these three together and I get an answer, that answer equals final velocity squared. I do have to take the step of taking the square root of the answer so it just equals final velocity. And when I do, I get 10.8 meters per second. Now, what can I do with that particular bit of information? I can go right over here and erase that question mark and add that to the bank of information I already have. The object's in motion. It's not doing anything different. I'm not starting a new problem. Therefore, that final velocity is relevant to any other question I might ask about this object, including how much time it's going to take for the change of velocity to occur. And that's the next piece we take on. I now have 4 pieces of information on my list, and I'm solving for an unknown. At this stage of the game, I kind of have a lot of options as to what I could choose to solve for time. But I always default to this one when I can. It's just nice and easy. And surprisingly, it's very versatile. The acceleration definition. I know my acceleration is 0.21 meters per second squared Final velocity is 10.8 meters per second, minus the 0 for the initial, so I'm not going to bother to write that, divided by time. When I solve for my time, it comes out to be 51.4 seconds. And I ask myself, does that make sense? Well, my acceleration is very small, and my change of velocity is pretty big. So it's not an unreasonable value at nearly a minute for this to actually occur. So in working with the idea of kinematics formulas, 1, read your problem. Read it all the way through. Don't just start trying to grab a formula out of the air. Read through the entire problem. 2, make a list of information. Make sure you have both the variable and the value on your paper. You have all of it in one place. You're not trying to look between your paper and the book or something along those lines. Choose a formula. And it could be more than one. Some problems will take more than one formula to solve. But as long as you have your list of information, you can figure out which formulas those might be. And finally, go ahead and set up your problem. Simply take the information from your list and drag it straight down to where it actually exists in your formula. In other words, it's really a plug-and-play type of situation. And 5, solve. You can have a step 6, and it's one I encourage highly, and that is evaluate. Does the answer make sense? Does it make sense in terms of the size of the answer and also the sign? We know sign is going to designate direction. So is it the right direction for the answer? And does the size of the answer fit in with the scope of the problem? Or maybe is it too big or too small?